How to master real-time inference with Kafka Streams. In this video, you'll learn to implement real-time inference using Kafka Streams, a crucial skill for processing large data streams and making instantaneous decisions. Welcome to our deep dive into mastering real-time inference with Kafka Streams. Did you know that over 80% of today's data is unstructured and flows in real time? Kafka Streams is a powerful tool designed to process this data efficiently, allowing businesses to make instant, informed decisions. In this video, we'll explore how to set up a Kafka Streams application, integrate machine learning models, and optimize your setup for performance. Whether you're a data engineer, software developer, or a tech enthusiast, this knowledge is invaluable for harnessing the power of real-time data. So, let's get started. Before we dive into Kafka Streams, we need to set up our Kafka environment. First, download the latest version of Apache Kafka from the official website. Extract the files and navigate to the Kafka directory. Start by configuring Zookeeper, which coordinates distributed applications. Use the command /bin/zookeeper server start.sh config/zookeeper.properties to launch Zookeeper. Next, configure your Kafka broker with /bin/kafka server start.sh config/server.properties. Now, create topics that will host your data streams using /bin/kafka topics.sh create topic your _ topic partitions 1 replication factor 1 bootstrap server localhost :9092. Verify your setup by producing and consuming test messages. Remember, the most common hurdles are related to port conflicts and incorrect configurations, so double-check your settings.
Now that your Kafka environment is set up, let's build a simple Kafka Streams application. Kafka Streams API is a client library for building applications and microservices. It offers a simple yet powerful way to process streams of data. Start by creating a Maven or Gradle project and include the Kafka Streams dependency. Your application must define a topology, which is a graph of stream processing nodes. In the simplest form, your application will read from an input topic, process the data, and write the results to an output topic. Deploy your application by executing the main class, and test its functionality using sample data. This foundational step is crucial as it sets the stage for more complex stream processing tasks.
Integrating machine learning models with Kafka Streams allows for real-time inference, which is essential for responsive and intelligent systems. First, choose the appropriate model for your needs, whether it's pre-trained or custom. Next, decide on a model serving strategy. You can either embed the model directly in your Kafka Streams application or serve it as a separate microservice. Use REST APIs to facilitate communication between Kafka and the model service. As new data enters the Kafka stream, it triggers the model to make predictions, which are then outputted to a results topic. It's also important to manage model updates seamlessly, ensuring minimal disruption to your inference pipeline.
Data latency is a critical factor in real-time processing. High latency can diminish the usefulness of your predictions. Begin by understanding the sources of latency, data transport, processing time, and system overhead. Techniques such as data compression, efficient serialization formats, like Avro or protocol buffers, and minimizing data hops can significantly reduce latency. Implement windowing to group incoming data over time intervals, enabling timely batch processing. Utilize local state stores to cache frequently accessed data, reducing retrieval times. Regularly monitor latency metrics using Kafka's monitoring tools to identify bottlenecks and optimize your pipeline for quicker response times. For Kafka Streams to perform at its peak, optimization is key. Start by tuning Kafka's configurations, adjust the number of threads, buffer sizes, and commit intervals to match your workload. Implement parallel processing strategies by increasing the number of partitions, allowing more consumers to process data simultaneously. Careful resource allocation is vital. Ensure your application has adequate CPU and memory to handle peak loads. Understanding and managing backpressure, which occurs when a system is overwhelmed with data, is crucial to maintain performance. Utilize performance testing tools like JMeter to simulate loads and identify areas for improvement. Effective monitoring and debugging are essential for maintaining a healthy Kafka Streams application. Set up monitoring tools like Prometheus and Grafana to keep an eye on key metrics such as throughput, latency, and error rates. Regularly track these metrics to ensure your application is performing as expected. When debugging, focus on common issues like configuration errors, misbehaving code, or resource constraints. Implement logging best practices to capture detailed information about application behavior, which is invaluable for troubleshooting. Leverage Kafka's Control Center to visualize and manage your Kafka environment efficiently.
Scaling Kafka Streams to handle large-scale inference requires strategic planning. Employ horizontal scaling by adding more nodes to distribute the load across the cluster. Implement load balancing strategies to ensure even distribution of data and processing tasks. As your data volume grows, managing high throughput becomes essential. Consider increasing partition counts and optimizing consumer configurations. Effective cluster management involves regular monitoring, updating configurations, and ensuring redundancy to prevent data loss. By following these scaling best practices, your Kafka Streams application can grow seamlessly with your data demands. Congratulations on mastering the fundamentals of real-time inference with Kafka Streams. We've covered everything from setting up your environment to optimizing and scaling your applications. Now it's time to apply these skills in your projects. Join our community by commenting below with your thoughts and questions. Don't forget to subscribe for more in-depth tutorials, and let us know what topics you'd like us to cover next. Together, we can continue to explore the exciting world of real-time data processing.